Have you ever tried creating an AI agent which perfectly runs in a local environment, but the moment you start deploying that in a production environment, it's lost its mind. It's not connecting with tools, it's giving hallucinated information, and nothing really working out. It's keep getting in the loops. So if this is happening to you, trust me, you're not alone. There are a lot of buzz about building up billions of agents, but somehow companies are not really doing it well, because every team, every member is really going behind shiny tools, frameworks, APIs, LLM abstraction layers, and multiple other things, but they are missing the most important aspect, which is system architecture. Hello friends, my name is Rohit Kamble. I'm an enterprise AI architect working with large enterprises to build real-world AI applications. In this video, I'm breaking down a highly practical code-first blueprint to build a responsible and production-ready AI agent. So let's get started. Before jumping into any single line of code, let's try to understand what AI agent is. So consider that AI agent is your assistant, right? It can really understand your intent. It can take an input from you. It can have a mind, a reasoning mind, which can be connected with a model. Then based on your query, it can also connect with tools to get the exact information which you are really looking for, and with that information it can again validate that with the model which is connected with, and will provide you the exact information. Now during this transaction or conversation, it can also maintain a history, so next time when you will ask any question, the agent will understand the history of that question and will use that with the context and give you the accurate understanding, so you don't have to repeat yourself. So that is what the AI agent is. Now, when to you really use an AI agent versus a conventional software? So from long time, we are building up a lot of conventional softwares, workflows, applications, microservice applications. So these are really going well. Yes, I think these applications are really sufficient. But say like you are trying to solve a problem, and that problem requires a complex decision making. It has a volatile rule sets. It needs to work with the unstructured data. If your problem really can get defined with these characteristics, then yes, you need an agent, and that's where you have to start building up an agent. But if you feel that your application or if that your problem is not required any decision making, or it can go with the checklist kind of a scenario, then you don't really need an agent. So you can really go with the traditional software. Which agent we should be really building? So look, there are two types of agents which we can really define. First agent, which can act as an independent agent, which can just run independently, as we mentioned, that it can have a model access, a tools access, and a memory, and it can get the job done. Then definitely that's a single agent approach which we can really go with. And then there is another option which act as a manager agent. So in this regards, a manager agent can have multiple sub agents or an assistant agent, and then manager agent will only connect with users, will get the query from users, and based on the user's intent, it will understand that which agent I need to really go with and connect with, and then it will connect to that particular agent, will get the required information out of that agent, and will pass that back to the user. So these are two different approaches we're talking about. A single agent which can really work independently, or can work with a group of agents, so every individual agent can connect to each other and can get that job done. Or you can have a manager agent which can have all the understanding and will send that information back to the underlying assistant agent and can get that information. So single versus multi-agent. My advice: start with a single agent system first. Let it execute in a runtime loop until it hits an exit condition, like a successful tool output or a maximum turn limit. You can manage immense complexities by simply using smart prompt templates with a dynamic variable rather than fracturing your code too early. But when do you split into a multi-agentic system? Look for two red flags. Complex logic overhead when your system prompts are drowning into if-then-else condition, or tool overheads when you have more than 10 or 15 overlapping tools and the model start getting confused about which function parameter to call. When you hit that wall, you can deploy two patterns. A manager pattern, when a central orchestration agent call specialized sub-agent as tools, or the decentralized pattern, where equal poor agent use explicit handoff function to shift conversation states directly to each other, like transforming a client from general triage to a specialized order management agent. Now let's talk about guardrails. Here is where the enterprises really fails. You cannot scale a system without a layered defense mechanism. Don't just rely on prompt engineering to keep your model safe. Layer in rule-based characters limit, regex filters to block SQL injection. Layer in rule-based character limits, regex filter to block SQL injection, and concurrent LLM-based classifier to detect jailbreaks, prompt injections, or PII leak in real time. These 5 things are very crucial when we are really building any kind of a guardrails against an AI agent. Also crucially, plan for human intervention, especially in early development. You must independently automate Tripwires if an agent hits a high risk irreversible action like authorizing a large financial refund or modifying production infrastructure, or if it exceeds a failure threshold of 3 retries, it must gracefully halt execution and hand the loop context over to human operator. Don't get into a hype of building up billions of agents. Okay, start small. Start with a single agent. Make sure your agent is having a best possible model connected. Give it a proper tools. Give it a memory so it can give and it can understand that what your intent is and can give you the real results. Don't just get into a confusion about building multiple agents or a manager agents on all those concepts as of now, and ensure that your agent is well connected with observability, with role-based access control. It has proper guardrails in place, it has all the system prompts which are really required, and have a proper evaluation and a complete agent of life cycle around your agentic application, because that is very required. Look, once you have this one single agent created with all these best practices, with all this production readiness, believe me, scaling those applications, scaling those agents into billions of agents will not be that hard. So that's it in this particular video. In the next video, I will be breaking down a real practical scenario about an agent. We will be talking about how we can develop a voice-based agent, because that's what I feel is the future is. Nobody is going to have a normal input typing based in conversation. Everybody will soon be moving to the voice-based agent. So in the next video, we'll be talking mostly about how you can develop a voice-based model, which are the best practices to be developed, what are options available in the market which we can really integrate with our voice-based model. So stay tuned and see you in next video.